Hi everyone. Today we're going to study Introduction to Fourier Series. First, let us define periodic function. A function f of t is said to be a periodic function if f of t is equal to f of capital T plus small t for all values of small t. The smallest positive value of capital T is known as period of the function f of t. For example, we have f of t equals sine t. Suppose we want to evaluate f of 2 pi plus t. The right side becomes sine of 2 pi plus t. When we evaluate the sine of 2 pi plus t, we will get the sine of t. And this sine of t is the same with our original f of t. The 2 pi here is the period of the function f of t. What about the Fourier series? A periodic function f of x which satisfies certain conditions can be expanded in a trigonometric series of the form f of x equals a sub 0 over 2 plus the summation when n equals 1 up to n equals infinity of the function a sub n times cosine of nx plus b sub n times sine of nx. The series on the right side of the above equation is called the Fourier series of the function. The coefficients a sub 0, a sub n, and b sub n are called the Fourier coefficients. Let's have the Euler's formulae for Fourier coefficients. In here, we will have the period 2 pi. This is the formula that we have a while ago for the Fourier series. We said that the coefficients a sub 0, a sub n, and b sub n are called the Fourier coefficients. Now, given the interval when x is between c and c plus 2 pi, this is a closed interval. The formulas are, let's begin with a sub 0. This is equal to 1 over pi times the definite integral with limits from c up to c plus 2 pi of the function f of x, then dx. What about a sub n? This is equal to 1 over pi times the definite integral from c up to c plus 2 pi of the function f of x times cosine of nx, then dx. For the b sub n, this is equal to 1 over pi times the definite integral with limits from c up to c plus 2 pi of the function f of x times sine of nx, then dx. This is our formula. Now, sometimes it is given that c equals 0. So the formula for a sub 0, a sub n, b sub n will be like this. Notice the change in the limits of integration. It becomes from 0 up to 2 pi respectively. Then, when c is equal to negative pi, the limits becomes from negative pi up to pi respectively. In our formula here, take note that our a sub n and b sub n will have the formula that requires integration by parts. We will study this in the next slide. We have this Bernoulli's generalized rule. The following rule of integration by parts, called Bernoulli's generalized rule, is mainly used for finding the Fourier coefficients a sub n and b sub n. If u and v are two functions of x, then using Bernoulli's formula, it will be like this. The integral of u dv is equal to uv minus u prime times v sub 1 plus u double prime times v sub 2 minus u triple prime times v sub 3 plus and so on, where u prime is dy over dx. U double prime is equal to second derivative of y with respect to x. U triple prime is equal to third derivative of y with respect to x. V sub 1 is equal to the integral of dv. V sub 2 is equal to the integral of v sub 1 dv. The v sub 3 is equal to the integral of v sub 2 dv, and so on. The standard results will be like this. Number 1, for the sine nx, this is always equal to 0. Second, for the cosine nx, this is equal to the quantity negative 1 is raised to power n. In here, n is any integer. Let's have these Dirichlet conditions. These are sufficient conditions for the existence of the Fourier series of function f of x. A function f of x is expanded in a Fourier series in an interval from a up to b. This is a closed interval for x if, number 1, f of x is well defined and single valued, except possibly at a finite number of points in open interval from a to b. Second, f of x has a finite number of finite discontinuities and no infinite discontinuities in the open interval from a to b. Third, f of x has only a finite number of maxima and minima in the open interval from a to b.